Hello. There are many methods that can be used to model this spring, but for me, I'm going to illustrate to you the most robust, simplest method that will always ensure that your spring will never ever fail. Your spring is regenerating parametrically, has relations deriving various parameters, like now, for example, if I change total length, if I regenerate, my spring will always regenerate without failure. Let me show you how you can model the spring in the best way ever. I'm going to start a new part here. I want to give it a name for now, and these are the parameters. I'm going to focus on the. Let me just snip this. Um, On this one, I'll focus on the center line here, central curve. Central curve is the best way so that I can sweep the profile. Therefore, I'll focus on that, but I'll also ensure that other geometry is not affected. This is a free length that defines the center to center of the middle central curve. And these are the parameters. We have wire diameter here. We have this the wire diameter, this the body length from here to here, wire diameter, this wire diameter, the value we are going to sweep, the middle curve, pitch, the distance between two coils, and overall out OD of the wire. Therefore, let's now model this approach. We're going to model this top section like that, bottom section as well like that. Then I'm going to put one complete construction circle to present this OD, and another one complete circle to represent ID. Then I'm going to connect them. Then this length is the wire diameter, and do the same case on the bottom side. Then another sketch to define the body length here as well. Yeah. Then we're going to sweep that. Let's see how we can do that. Moving that to another screen here. First thing I'm going to do is on the front plane, I'm going to uh, insert center lines. First center line, second, third, fourth. And on this center line, first circle, and this is the circle that represents the OD or the wire. For now, I can just dimension it 30 because OD is 30. And as well, this one here supposed to not pass through the center there. And I have another center line here. Of course, this one its purpose. This let me first for delete it so that we can model this one in the simpler method. Let's go. Let me just hide the planes for now. Yeah. Then on the bottom here, another circle like that, and these two are supposed to be equal. Yeah. Let me first delete that one. It's for the reference for now. Then I need to another one here, another circle. As I said, we do another one, 3 circles as well as here, middle, and one down here, and they are supposed to be equal. These two equal. This to this equal. All right. No worries. I'll show you. Then this one here, to this one here as well, like that. This is the OD for construction, as well as this. This is the middle. This is the one to present the middle one. This is the inner diameter for construction here as well for that. Then I need to pull a point on this point as well, because I want to trim that side to present that section of the spring as well. Another point here, and trim this one here, so that for them to alternate. And the free length is this distance now. This is the body length. That's the distance. For now, supposed to be 50. Let me just write 50 to ensure that my sketches are not spread. And I need to hide these constraints. Well, let me hide those constraints for now. Okay, the first thing I need to do, let me first delete that dimension for now. Yeah, I need to define what we call free length, distance from this point here to this point here. Hence, I need a point on that point and that point there to define that is a free length from here to here. That is 100. It is a free length. Then I know from this is the wire diameter. Hence, if I put another point here, so the point for construction, another point here, I can define this length from here to here. I can do that as 5. That's my wire diameter, as well as here. You can see it automatically changed. Then I know that this one is half this. Therefore, I can connect this. I can now define this parametrically. This is how I'll do about it. From this point to this point, dimension it for reference. Not that. I meant from this to this vertically, and from this to this as well vertically for ref. Then select these two and say select this dimension, say equal, like that. Then I can delete that or do a ref. You can see now becomes from here to here 2.5, 2.5. That is being controlled by this 5. If this 5 changes to 10, this becomes 5. I'm just using this dimension wire to drive those. In the free length here, if I try this to be 200, everything is rebuilding without failure. Okay. Then this one is the wire diameter 30. Even if you change this to 40 or 50, nothing will fail. You can see the model is okay. And I only need to define that, and this height. Okay. Then let me now insert another center line here, like that. And we will see that this is 50. Or we'll see that this one is 100 minus, we are getting this as 100 minus 25 and 25. Basically, we are subtracting, we are taking this 30 minus diameter. We are to get this dimension. We are getting 30 minus diameter to get 25, as well as the other side. Okay, that's how I got 50, because there's 100 minus 30 for bottom side, minus 5, another 5, 2.5 and 2.550. Okay, keep that in mind. It will be important how you're getting this. If this one is 150, this becomes 100. Now this one, yeah, because this 50 is the distance from here to here. Can do, let me measure for you. From here to here, from this point to this point is 25. It will always be 25. You can see, or 25. Therefore, I don't need this one here. I don't need this one here. I don't need them. They're just for references and to explain to you. Even this, I don't need it. I just need only those 3 dimensions for my spring. And now I can go to tools, relations here. But once I select relations, you can see now my dimensions, they are SD17, SD18, all are those. The best way, cancel, just go OK for now. Select this one here, sketch, D1, go to tools, switch dimensions, and here you can now dimension, you can now give them a name that makes sense. You can call it free length, not change my keyboard here, free length, like that. This one is a D2. D2 is the wire diameter. Then lastly, spring diameter. Spring OD. Let me use the spring OD to present spring outer diameter. Call it OK. If I go back to this, I can go back directly to relation and just select here equals wire diameter 5, spring outer diameter, we say this equals 30, free length we said equals 100, like that. Therefore now I can control these ones from a relation here. When you say verify, relations have been successfully verified. If there was a mistake here, like that, you see we see that error. Therefore it's good to verify to fix any issue. Okay, now you can see that's fine. Next is this one is called, you can give it a name here, which is a spring geometry, like that. Next is, let me show my planes. Onto this plane, I'm going to now to design my free body where we'll get the colors. I'm going to use this point as my reference, cross, like that. And I'm going to use center line here. If you activate lines, these ones here, I'm going to want to use a center line here. I prefer using the center line for it to exist, that, like that. If I don't need to dimension that height, I just come here from this point, then another center line from this point here to this point, then a line from here to here, dimension from this to this, back to this, click to get 60. This one is 60, but you can use a relation as well. Say SD1 is supposed to be 2 times spring OD. Spring of diameter supposed to be 60. Yeah. And of course, you know the height is supposed to be 50. For now, is a reference. Okay. This one is called it what? We are going to give it a name that is the body length. Body length geometry. And in the body length, it's a good idea as well to include where your circle will begin. My spring will be here, but I'll make it for construction, and can go back to relations here as well. Say this one to be this SD3 SD3 equals spring wire diameter. That verify. Okay, come here, see okay, like that. You can see now this one will represent my spring size. You can see. Next is now to sweep. Go to model, now select sweep, helical sweep. For the helical sweep, you have to define what profile. This is my profile. It takes the internal axis. This is that axis I used. It selects that axis automatically. If I go back to the body length here, if I put this center line, it will be visible to you like that. You can see this is the center line that is still visible there for you. You can see these center lines are as well visible. This is the total length here from here to here. If you want to know the total length of the spring, basically select these two and measure and get 105. That's the reason why I said let's have these ones to allow you measure the total length in case you want to know the total length of the spring. Therefore, I go back to helical sweep, this one here, change from get from bottom, okay, and differences here. Select this one here, select this one here, solid sketch. You can see the circle we had is highlighted, but you cannot reference this circle. If you try to select it, you can, but you can't reference it. You cannot. Therefore, just reference here and just give it a dimension. And go to relation again, tools, relations. This one here SD2 equals wire diameter. You have to make also the spelling has to be right. Yeah, there's no, yeah, I made a mistake where diameter. Yes, like that. 5. Then say sketch. See okay. Now we are getting I'm getting my spring in this is the pitch. Now this is the pitch. And there are some parameters here that are very important on what you are going to do next. If you want to go, you can go clockwise or counterclockwise, and you can use a surface like that or body. If you want a surface, you can as well do a body thicken, hollow, yeah. Okay. Then I'll show you section orientation. These three, we are going to apply them. You see how they are applied. But for now, let's progress. If I change 10 pitch, you can see the distance increases. If I say 5 here, this is the body length like that. But if I change the body length here to 100, if I go to tools, relations here, free length from 150 to 150, control G, the spring doesn't deform, it gets more coils. You can see the coils are just incremented, but for me I want, once I change my free length, once I stretch my spring to stretch, let me go back to how it was here. I want now to control the pitch. I have this pitch here. I want to control this pitch using a relation as well. Let's first select here and go to switch to dimension. This one is my, and give it an a dimension here. Call it pitch. Right now my pitch is 5. That's fine. I'm going to go back to tools relations here. Remember how I said how to get the pitch? I said pitch will be equals to, we said it will be free length. You have to subtract, you subtract what? You have to subtract spring OD. There was a spring OD. In this spring OD, you have to subtract wire diameter, or just spring OD, like that. Let's do like spring OD times 2. 2 because of top and bottom, like that. As well, wire, we have wire diameter, top and bottom, minus therefore 2 times wire diameter. If you verify this, let's see. We are getting 5 now. Yeah, if you go back to the sketch here, what is pitch? This is a free length, and I'm saying I took this wire diameter from here to here. We have this one here and here to here. From here to here, subtract and subtract this. Yeah. If now I go back to relation, change this to 200. My spring, can see how it behaves. Let's see. Let's go back here to see 130. You see, made a mistake. And I hope you have tried to figure out where we made a mistake. Let me go back here. 100. Control G. Go back here. Can see. Therefore, let's go back to 5. 5 was cancel. Basically, what is happening here? Pitch. When this was free length was 100, we saw the body length was 50, the pitch was 5. Basically, the formula we are using to calculate pitch, let me just write it here. Pitch is supposed to be equals to, initially, it was supposed to be free length, like that, which is 100. Body length is 50. If you minus body length 50, let me just go back again. Yeah, for you to understand. We are saying pitch is 5 initially. This is the initial pitch. Initial pitch. When initial pitch was 5, what was body length? It was 50. Hence, ratio of body length to pitch must be of body length to pitch must be cos a constant 0.1. It is a body length because it's 50 divided by 50 divided by pitch. The other way, I want pitch to body length. Yeah, pitch to body length, that is 5 divided by 50. Yeah, let me just take this lecture here to body length. Yeah, for me, I just want to use pitch to body length is 0.1. Therefore, this one pitch I have to do what now? The pitch has to reduce by 0.1. You see, okay, let's see what happens. Let's go back here, go to here. You're getting a pitch of 3. Let's see what is why we are getting a pitch of 3. Pitch 3. The equation, okay? 3 length, 3 length is 100 minus spring or diameter minus 60, 40. Here we made a mistake here. Sorry for that. This one is minus OD. This is supposed to be minus spring diameter. Not spring, wire diameter, like that. Then multiply by 2. Yeah, because we want to get 30 minus 5, that is 25. Multiply by 2 to get 50. Yeah, it's an error here. Length 2 minus this. Where's the error? Yeah, spring minus it. Okay. 1, 2, 1, 2. Yeah, need an extra bracket there. Yeah. And now it's okay. Control G. Let's go back to the helical spring here. We are getting 5. Yeah. Let's see what happens when this becomes 150. We are supposed to get 150. 150 minus 50, 100. We are supposed to get a pitch of 10. Let's go ahead getting a pitch of 10. Yeah, we are getting a pitch of 10. Now we can see our relation is functional. Okay, let's now progress to the next stage. Let's just go back how it was. The next stage is connecting this here to here. Remember, we need to get this here, this section here, top section, like that. Hence, we need now to connect this to this. But if you can get a point here, go to model, you can put a point here. That's possible. But putting a point here, this one is not as exactly like this one is not exactly perfect circle with relation to the point. You can see you can select that. But let me illustrate something here. If I have a circle, circular profile like that, circular body like that, if I can put a point just for hide this axis here, I can put a point on the middle because I just go to the point, select this edge here, and here references I can say center. My point go to the center like that. But if I try here, isn't possible. Yeah. Therefore, I just need to sketch, and I just select the center line here from this point, and use this point, datum point there. Therefore, if now I can easily use a datum curve from this point here, and I want this curve to be tangent to this, the other direction, and here you can see maybe I want it to be normal to this face. Then say okay. But when I go to top view, this doesn't look good. It might not function. Doesn't look nice. You can go to options here, tweak curve settings, and select one point here. Tweak it. I can tweak a little bit like that. Maybe like that. Maybe like that. Now it looks better. Then I can just select this curve bottom one here. then say sweep, then shift, add this, then on the solid sketch and do what we call a circle here, and that will difference the other edge, do a sweep. But you can see uh, we don't have anything. You can see there's no sweep, but when I change to surface, I can see a surface being created. What is happening? Someone might, what's happening now? Yeah, you can be tempted to see, okay, I can create, I can't create a solid, but I can create a surface. Yeah, it's good to get this type of errors so that you can learn how to troubleshoot them. Someone might be tempted, okay, I have a surface. All right, let me go to the surface here. Let me just go to options, cap edge. This edge will be capped such that if I hide this body, if I hide this, let me just go to body, hide this body. I have a surface here. Let me solidify this to become a solid. Yeah, sometimes you can say, let me try to do something. Okay, I can see I can't be able to solidify that surface. Why? Let me try to do the quilt. It's one surface. Okay, solidify. Feel it doesn't solidify. What's happening? Yeah, sometimes you have to experience these types of errors so that you can be able to troubleshoot them. Someone might say, okay, I can solidify. Let me try to thicken this. The other side. It can't thicken. What's happening? Okay. Uh, Let me try something else. Let's go back to the sweep and go back to solid. Delete this profile and use a small radius. See, maybe something, okay, a small radius now is functional. Maybe the radius is the issue. Okay, let me now change from small to big radius. Big radius is functional. What's happening? Therefore, my profile is okay. Therefore, let's go back here to surface and try to take this and solidify. Is functional. What's happening? What's happening? Therefore, for me, you might, because why am I saying this? Because if your curve, maybe there's a step I skipped. There's something I should have mentioned to you. If this curve is too like that, how it was, remember it was like that initially. This cannot create a profile, a sweep, because we'll have self-intersecting. If I go back, you can see magically it created. It should not create because of that self. Yeah, it can't create a solid. It just creates a surface. If you try a solid, for some reason it's creating. Yeah, but there's sometimes depending on how your curve is, it may not create. Let's go. Yeah, let's go back to this curve here. Let's go to options, tweaking. Maybe I try that with the bottom one. I try that the bottom one to see if it will create or not. Let me return how it was, because sometimes depending on your trajectory, the sweep might not be formed. Let's just do it like that. Okay. Okay. Let's now proceed how you are. We said okay. Therefore, the diameter, we have verified this diameter doesn't matter. Let me now do another circle. Instead of snapping to this, let me now give it 5. What is happening? The 5 doesn't function. But if you go smaller, if you go larger, it functions. Okay? I'll, Let me just leave it like that. I'll tell you the reason why this is happening. If you zoom here closely, we said this curve be normal to this. Okay, what you can do, there's something I want you to see. I'm going to change sketch to something very small, 5.001, or maybe 4.9. Yeah, let me just try 4.9. When you zoom here, let me just let me first for use what we call, let me first for you to see, let me section. Yeah, like that. Front. When you zoom here, this curve tends to go up. Maybe this one might not be clear. Let me use a surface, because surface is so we can get it. Like 5. Yeah. Let me now go back to front so that you see it. If you check closely, this edge moves like this. This edge, because the helix is supposed to go up, the curvature is like this. But now we said this to be normal. That's what we said. Therefore, let me change my pen for you to understand. Therefore, my edge tends to go like this. You have this gap. Okay. Something else very important I want you to understand here is, if I go to this sweep here, change. Remember when I said about section orientation? If you zoom here very closely, you see that this section here, we said through helix. Through helix, there are two ways you can do a through helix or normal to helix. When you say normal to helix, it means that the cross section will always be normal to helix. But when you say through axis, it means that this section here, this point here, will always be parallel to this. Will always be parallel at that point. Okay? But when you say normal to trajectory, we are saying that this section here will always be normal to the trajectory. The trajectory is a helical trajectory. When I select create helical trajectory, it creates internal trajectory. That's an internal trajectory. Let me hide this first for you to see. Let me suppress it. You see, when I select option create helical trajectory, we have this trajectory here. This trajectory here. When I say helix through helix axis, you see, this is uh will always be perpendicular to your axis. But when I say normal to trajectory, this is normal, this trajectory. Okay, let me now go back to the shaded here, front. When I say normal to trajectory, we are getting a small gap here, but this material is interfering, digging in. Let me go back to what it was default. So this one being straight like that. Let's go to default, but let's create helical trajectory there. I want to go back to this curve definition. Remember we said normal to that surface. We are going to, now instead of normal to surface, we are going to change this endpoint. We said normal, we're going to say tangent to trajectory instead. Therefore, this one is now tangent to the middle trajectory. Instead of normal to the surface, now tangent to the trajectory. See, okay. Let's now go back to this one and see what happens. You can see there's some interference here already. But by selecting that, I should not have deleted this. Um, by selecting that option, the issue we had, what's happening here, and the election, uh, yeah, go like that, front. The issue we had, we fix it. It is fixed when we said that this curve to be tangent to the trajectory. You can see now this one is, it has a very good tangency continuity. But now you have an issue here. See this gap. This gap is created because of how this helix is created. Therefore, you have to change to normal to trajectory as well. But now when you say normal to trajectory, issues are there. Sketch gets broken. You can come here to redefine the sketch, make it to be right, sketch, cross. You have, yeah, first for cross here. Looking for the, okay, should have this first click here. First so fast for cancel. Cancel first. Yeah, to suppress this like that. To go back to the sketch, edit the sketch. I want the front, let the front, top to be top, top to be top sketch. Yeah, and now we need to select more references. I need to do that. Okay, now my curve can't get my point, as I've lost my point. Now this point, I need to get a point here. I need to get a point. I'm supposed to sketch onto this face. Get a point back here. Okay, I messed up here. So delete everything. I need to select this as my reference here. Fine. Get out that later. Do this. Okay, I see we are getting problem. Let's go to this one here. Basically, to save time, let me just delete that sketch. Yeah, create a new sketch. The sketch here. Yeah, let's just click this sketch. We create another sketch here. That's not the best way to do, but do it right now. It wasn't good. Go back to geometry. Yeah, that's the reason why I wasn't able to select this surface here. Yeah, that's okay. Yeah, let's do another sketch, quick one here on this surface here. Sometimes just do a new sketch to save some time, especially when you lose references. What is happening? Yeah, you just suppress you come here and suppress, fine, come here, edit you. Oh my, you have this curve looking for this, that, delete. Let's see references, information, references. We have lost a reference here. Here, okay. Right, I see. Let's do another curve as well. Yeah, maybe we messed up something there. Tangent to this. Change this one here. This one here. Tangent to this. Go to options. Tweak. Top. Like that. That. Okay. Go back to this shaded. Okay. Come to this one here. You suppress you. Have issues. Now you come here. Edit you. That's fine. Yeah. Because I know the reason why. Reason why is delete this view. Use shift to select that and use a solid. The sketch 5, that's fine. Okay. Okay. See, okay. Yeah. Like that. You suppress you. Okay. Again, the bottom side, a quick sketch. That. I'm using this point so that it can be available for selection. Curve through point, this and this. You. Oh my. Okay. I selected many by mistake. Sometimes you have, yeah, when you see selecting things, just repeat it. Yeah, that tangent to this. What's happening? Sorry for that. Yeah, let me be slow a little bit. That's fine. Add tangent to this. I'm done. What is happening here? Let me go to free. This one here. Just go to tangent to this. Okay. Let's go back to this one to figure out what is happening. What is happening here? I used wrong point. My bad, my bad. My bad. I should have selected this point and this point. This point here. Let me just hide the sketch. This is confusing me. Hide it. Let me insert a point here. Yeah, now if the other point is okay. Yeah, now I should tell it. Yeah, now you're okay. Tangent to this. Yeah, sometimes it's good to get this type of issues. That's how you learn how to troubleshoot them. But sometimes you can get an issue in Creo, and if you don't know how to, if you haven't experienced it, it becomes an issue. Yeah, so somewhere like there can do like that. Yeah, I can easily select this here. I like selecting this first, selecting sweep, so that I can change the direction. Press shift, then select this one here, and do a sketch, and do that. Yeah, do okay. Then I like hiding all of them. I like using this first one shaded. Then select everything, go to view, give you some appearance, whatever you want. Yeah, like that. No? Now let's go back to tools, relations here. Try to change this to even 200 G. Yeah, you can see now our spring is functional as intended. Yeah. In my next video, now I'll go advanced, a little bit advanced. We will take this spring, insert this spring to an assembly that has motion, and you will see this spring extending back and forth. Yeah, it's be a very nice tutorial. Let's stay tuned.